We're going to continue our understanding of the periodic table by going over each of the periods and groups in the periodic table. We're going to be using this as a foundation as we're going over the periods. Now, our first group is on the far left, and we call these the alkali metals. The alkali metals are incredibly reactive, and they want to undergo oxidation. That means there is an electron on the outside that just wants to be pulled off by something else. Now, these metals will violently explode if they are exposed to air or definitely water. And because of this, we have to keep these metals surrounded in either an oil or noble gas, because these materials won't take that electron. They won't accept it, thus keeping the metal stable. The second group is the alkali earth metals, period 2. Now, this is the second column on the left, and these are metals that want to get rid of 2 of their electrons. They're much less reactive because they're a bit more stable, but they will react with halogens or oxygens and give away their extra electrons. They can be handled without special protective material, but they're not quite as reactive. Now we're going to jump all the way over to this other column here, and we're going to go to group 3, the boron group. The boron group, 5th from the right, is unique because it has 3 outside electrons and it wants to share these. Covalent bonds mean sharing, and it creates these unique triangular bonds with other materials. Boron, aluminum, gallium are the most common examples. Now moving on to group 4, next over, is the carbon group. The carbon group is unique because it has a tetravalent or 4-part bond. And it's the building block of life because carbons can react in so many unique and interesting ways because of these 4 bonds. It lets us pull off a lot of unique things in our bodies, so enzymes and proteins and stuff like that can work using that. And the next one down, moving into the semiconductor range, we have silicon, which can form unique bonds like carbon, but we can use with electronics. Moving on to the nitrogen group, which is 4th to the right on the periodic table, creates 3 three-way bonds, but at the same time, it has an extra electron pair, so it creates a pyramid shape instead of a triangular shape, what we would see in the boron group. Next up is the oxygen group. This is one of our reductors. A reductor meaning it's going to accept electrons undergoing reduction, and because it can accept these bonds, it is known to react easily. Thus, a lot of our enzymes, a lot of our chemical reactions require oxygen to function. That's why you have to breathe in oxygen so you can pull energy, specifically in the electron transport chain inside of mitochondria. The next group is the halogen group, and these are really strong reducing materials. You have to keep them isolated because much like the alkali metals, will react violently and form salts, and they will steal an electron immediately. That is the halogen group. Now the last group, the farthest to the right, is the noble gases, previously inert gases. These are extremely non-reactive. We didn't think they could react at all until a Nobel laureate tried really, really hard. We commonly store things in noble gases to keep them from reacting. And if we want to prevent any kind of chemical reaction, we will use any of the noble gases from xenon up. We don't use radon because it's radioactive. Now, the middle of the periodic table is the transition metals group. And what's unique about the transition metal group is they have multiple electron configurations. This is due to having another shell called a D shell. Not to go into too much, it can trade electrons up and down on its outer level. So everything in this part of the periodic table has at least 2, sometimes more, bonds that it can form. And it includes some metals like iron and gold and copper and mercury. Moving down to the bottom of the periodic table, and right here next to barium is where we'd slide it in, is the lanthanide group. The lanthanides are a special type of elements. They're most unique because you can create very special materials like super strong magnets with neodymium in particular. These materials are typically explored in college rather than high school level. And lastly, at the bottom is the actinide group. The actinide group, and they would fit in right here with next to radium, is often radioactive and highly unstable materials, but because they're unstable, they can create all kinds of interesting things. This includes uranium, which 235 isotope you can split and undergo nuclear fusion for both nuclear bombs and nuclear reactors. Plutonium, which also creates very potent nuclear fission reactions, as well as humble thorium, which is the latest nuclear power we're trying to work with now. That has been an overview of the periods and groups of the periodic table. If you have any questions, here's our emails. Thank you and have a good rest of your day.